This is problem number 22 of the 2012 AP Calculus exam. Let f be the function defined by f of x equals the natural log of x divided by x. What is the absolute maximum value of f? Well, let's go ahead and look at what we know about maximums and minimums. We take the first derivative and set it equal to 0, and that'll give us a relative maximum or a relative minimum. And so we can start with that to begin with. So if we have f of x as being equal to the natural log of x divided by x, then if we take its first derivative, and noticing that I have a quotient, I'll use the quotient rule, and that's the derivative of the first times the second minus the derivative of the second times the first over the second squared, where the first term is the numerator and the second term is the denominator. So the derivative of the first term, the natural log of x, is just 1 over x, times the second is x, minus the derivative of the second term is 1, times the first, the natural log of x, over the second term squared, so x squared. We can simplify, and I notice that the x's will cancel, and that will leave me 1 minus the natural log of x over x squared. We said we were going to set that equal to 0. And if we do so, now we can multiply both sides by x squared and get 0 equals to 1 minus the natural log of x. Adding the natural log of x to each side, we get the natural log of x equals 1. And we're solving for x, and we know that the natural log of e is 1, so x is equal to e. Next. Now we know that x equals e is a possible relative min or max. How can we tell whether it's a maximum or a minimum? Well, we can look at the second derivative and consider the concavity at that point. So at the first derivative of x is 1 minus ln of x divided by x squared. Then the second derivative of f of x, and noticing I have the quotient again, I'll use quotient rule. I'll have the derivative of the first, which would be a negative 1 over x times the second, x squared, minus the derivative of the second, 2x, times the first, 1 minus ln of x, over the second squared, which would be x to the fourth. Now we can simplify, and we'll get negative x minus 2x times 1 minus ln of x over x to the fourth. And we want to find out what's happening at the point e. So the second derivative at e would be equal to negative e minus 2 times e times 1 minus ln of e over e to the fourth. So we have negative e, and I notice ln of e on this right hand side is 1, so 1 minus 1 gives me 0, and 0 times the negative 2e is still 0. So I'm going to have left in the top is this negative e, and that's going to be over e to the fourth. And I notice that that's going to be a negative value. So if f prime, double prime, of e, the second derivative at e, is less than 0, then it's concave down at that point, which would make this a relative maximum, and in this case an absolute max. So at x equals e, I find my absolute max, but I need to find what is the value of that maximum. So what we have to do is substitute into our original function. So f of e would be ln of e over e, which is 1 over e, and that's my answer, 1 over e, letter B.